Suppose there are 20 students in a classroom. 3 of them are 15, 2 of them are 17 years old. We have 3 19-year-olds, 5 20-year-olds, 3 of them are 22, and the other 4 are 23. We can find the total number of students using this formula. So there are 20 students, as we already knew. If we want to choose a student, what is the probability that they are 20 years old? We can calculate it by the probability formula. Ni is the number of students who are 20, and N is the total number of students. Let's illustrate the numbers on a histogram. If we add all the probabilities, it should yield 1. What is the most probable age? It is the age with the highest probability, which is 20. What is the median age? As we can see, there are 10 students younger than 20 and 10 students older than this age. So the median is 20. What is the average or mean? Let's calculate it. As you can see, the mean or the average is 19.7. Generally, we can find the average value of I using this formula. Now, let's find the average of the squares of I. We can use this formula and it yields 395.2. To talk about the data distribution, we might want to calculate how much our data is deviated from the average by finding the distance between each individual point and the average, and a weight summing over the distances, but as you can see, it's 0 and not very useful. Instead of measuring the average of delta I, it is more useful to calculate the average of delta I squared. We denote it by sigma squared. And as you can see, it is easier to use this formula instead. Sigma squared is called the variance, and sigma is called standard deviation. Note that the average of I squared is larger or equal to the square of the average of I. Sigma is 0 when every point in our distribution has the same value. For example, a class with 20, 25-year-olds. For example, for the class we talked about in the beginning of the video, the standard deviation is calculated like this, and it is 2.67. If you like this video, don't forget to subscribe here. We have similar formulas for continuous variables by introducing a probability density. Rho x dx is the probability that a point is between x and x plus dx. The probability that x lies between a and b is given by this integral, which is the area constraint under the density graph between a and b. We know the sum of all probabilities should yield 1, so this integral must go to 1, and the area under the graph is also 1. The average of x is given by this integral, and generally the average of any function of x by this one. Finally, for variance, we can use the same formula in discrete variables, but instead of using I, we should use x.